Alright, let's talk about Rome. Not the Rome you see in postcards with the scooters and the gelato, but ancient Rome. Imagine, if you will, 1 million people crammed into one city, all of them needing water. They needed it to drink, to cook, to clean, and maybe most importantly, to flush away the stuff nobody wants to talk about. The local river, the Tiber, was getting pretty nasty, serving as both a water source and a sewer. Not a great combination, let me tell you. So, the Romans had a big stinking problem. They were a thirsty and increasingly dirty a city that was outgrowing its own plumbing. So how did they pull it off? It all comes down to one simple, unchangeable force: gravity. The Roman engineers weren't using pumps or pressure systems, they were using a slope, a very, very slight slope. The goal was to create a channel that dropped just enough for the water to flow, but not so much that it would rush too fast and erode the structure. We're talking a drop of maybe a foot or two for every 1,000 feet of distance. That's a gradient so subtle you could barely see it with the naked eye. It's like trying to get a marble to roll slowly across your entire living room floor without it stopping or speeding up. It required incredible precision. To achieve this, the Roman surveyors, the guys called gromatici, were masters of their craft. They didn't have lasers or GPS. They had simple, brilliant tools. One was the chorobates, a 20-foot-long wooden plank with a water level carved into the top and plumb lines hanging from the sides. If the water in the groove was level and the plumb lines were straight, they knew their surface was perfectly flat. From there, they could calculate the tiny, precise downward angle needed for the next section. Building one of these things was a monumental undertaking. It wasn't a job for the faint of heart. Skilled masons, engineers, unskilled labor, Roman soldiers, thousands of slaves. Quarrying the stone, digging the trenches, hauling materials for miles. It was grueling, dangerous work. Battling heat, battling cold, the constant risk of cave-ins tunneling through a mountain. The materials they used were simple but effective. The primary building block was stone, massive, uniform blocks. But the secret ingredient was Roman concrete. This wasn't the same concrete we use today. Pozzolana, volcanic ash. Every aqueduct has a story. Take the Aqua Appia, built way back in 312 BC. It was Rome's first, and it was a game-changer. What's interesting is that it was built almost entirely underground. The builders were probably worried about enemies poisoning the water supply during a war, so they hid it. It was a practical, if paranoid, decision. The man behind it, Appius Claudius Caecus, was a bit of a character. He was a censor. He also built the famous Appian Way. The guy clearly liked naming massive infrastructure projects after himself. But hey, when you give a city fresh water in its first major highway, you've probably earned it. Then you have the giants, like the Pont du Gard in southern France. This thing is the supermodel of aqueducts. It's a 3-tiered bridge, staggeringly beautiful. A UNESCO World Heritage Site. It was part of a 31-mile-long system that supplied the city of Nimes. What's amazing is that the entire 31-mile aqueduct drops only 56 feet in total. That's an average gradient of 1 in 3,000. To build something that precise with that level of artistry using basic tools is just mind-boggling. Not all stories are about success, though. Maintaining these aqueducts was a constant, dirty job. The hard water from the mountains was full of minerals which would build up inside the channels like plaque in an artery. So special crews of workers, the aquari, had to regularly go into the dark, damp channels and chip the stuff away by hand. So, why are we still talking about Roman plumbing 2,000 years later? Because the principles they perfected are the same ones we rely on today. Look at our modern water systems. We still capture water from distant, clean sources. We still transport it over miles through pipes and channels. We still use gravity whenever we can because it's free and reliable. We have better materials, bigger pumps, fancy computer systems. But the fundamental idea, lead water from a high point to a low point where people need it, is pure Roman engineering. We've built on their foundation, quite literally. The legacy isn't just in the mechanics, it's in the concept of public health itself, providing free, fresh water to the public, building extensive sewer systems to carry away waste, massive public works that improved life for everyone, not just the elite, a testament in stone that shows when people unite to solve big problems, they can change the world forever.